they're mobile.
Yes.
Now, granted, something like calcium, not so mobile, but most of the macros are relatively mobile. Even magnesium is mobile-ish.
And even calcium, and we'll get into this a little bit more, but it's used as a secondary messenger. So even if it's not technically mobile, the fact that it operates in two different ionic forms,
moves in the transpiration
Ca2 plus, Ca3 plus, right? So it's that electron transfer that creates a lot of the education.
I'm gonna get a pen. Hold on.
All right.
I can tell this.
All right.
We're just in the submarine. We're going deep.
We're going deep.
We're Jug Dealers, we're the podcast you need in your feed. Teaching the game like you never seen. Jerin, Gabe, GRAMBO, true OGs. Masters of the globe, set your mind free. From Denver, Colorado, where the data's green. We set the data points for the SOPs. Jug Dealers Podcast, yes indeed.
Hey, everybody. Welcome back to the Jug Dealers Podcast, where we discuss all things cannabis and lifestyle related. Brought to you by the good people at 5e and available always at jugdealers.net and jugdealers.shop. Jerin, we are back.
We are back in the studio. We are back in the studio. Also want to mention real quickly, obviously, and we've been getting a lot of sample requests. Apologies for anybody that it's taken a little while to get to.
We're almost caught up. We're pretty close to caught up, though.
Good.
We're like maybe like 5-6 days behind, but we're caught up.
You can request those and fill out the form, and it's actually reviewed by either Gabe or I personally. But you can go to jugdealers.net/samples and see that. And yeah, man, we are back in the studio. Like I said, it's good to be here. As always, we want to do a little bit of, a retouch up on some of the things that we talked about earlier. Some of our earliest shows, we really broke down the macros for a whole show, the micros. We talked about biostimulants. We talked about, things that are plant beneficial versus plant essential. And we thought, you know what? Not a bad time to
put it in one.
Let's do it all. Let's just wrap it in
bow
one.
In one box.
Yes, let's put it in one box. Let's talk a little bit about just kind of rounding it out. What it really even means to be plant essential. I do want to mention something about this very quickly. Plant essential versus plant beneficial. There is a little bit of a dividing line, but understand that that's a moving line, right? So even as we looked up, like nickel only
in the late 20th century did nickel make it over to being an essential element, in which you're like, when you see what it does, you're like, how is it? We always talk about Linnaeus and how all these things have happened basically since the 1800s.
Sure.
As Jerin says all the time, there's still so much shit we just don't know.
We just don't know. We don't know. And this is a dynamic thing when it comes to the essential. What those 17, which is even, we have possibly even 18, possibly even 19 that we'll talk about, but part of it's instrumentation, right? So when you get into the the micros, it's truly micro. It's very, very, very small amounts. So to call it a plant essential, that means it has to be scientifically proven that it's plant essential, meaning, obviously certain experiments have to be set up around it and then able to be reproduced them. So again, from what I understand, part of it is literally it's getting into such small amounts. We don't even necessarily have the instrumentation to prove it.
And it's it's funny how you just made things click in my head because we always talk about that. Well, we always talk about the silica.
Yeah.
And we talk about how our silica, the reason it's so different is because the particle is so small.
Yeah. Yep.
Part of that being that's an incredibly small particle to be able to measure.
Yes.
So, dude, that's
why even, without even getting into this too much, but you don't even have a standardized test for what percentage of mononorthosilicic acid is in there. Well, and it's instrumentation.
And that's where we talk about the difference between fulvic and humic, because fulvic is that finer particle in there. But as you always say, the amount of instrument, even when we were at BizCon, they had a spectrometer that could measure from 360 and up, but realistically, the UV light is all below 360 nanometers.
It's outside of par.
And the instrumentation to measure that is it goes from a $2,000 spectrometer to a $10,000.
That's a big jump. Yeah, that's a big jump. Yeah. So obviously, we are limited to our instrumentation, even with something like, we were talking a little bit about VPD.
That's a really great point, bro. Yeah. That is a really, really, really great point, man.
And even, I'll mention as a small mention, because I think it's probably something that we're going to do a whole show on, but even VPD and really, what that means for the plant that we work with. And is there even truly established standards to it? Or is it better to just use it as a guide, understanding that not all of this has been proven with the plant that we typically work with, especially when it comes to, really proper humidities and temperatures based on really trying to create those positive stresses and oil production, because that's what's of horticultural significance.
Well, and that was a great discussion we had yesterday, just as normal, not on the show, but where, I agree with Jerin in the fact that the VPD charts that we look at are really they're not for cannabis. They're for a lot of other crops, in which I tend to get my best results running, a little bit below.
Well, just think about it. And again, this is kind of a rabbit hole that we're just opening up, but at the same time, I think we're going to do a whole show on it. But if you think about, okay, just as an example, maybe that VPD is for a leafy green plant to promote, leaf production, because that's what's of horticultural significance. Well, for us, that's just creating more plant matter. I want more oil. So it's a different plant, right? So just any way to get your people's heads kind of rolling. But today we're talking nutrients.
Today we're talking a different rabbit hole.
Today we're talking nutrients. But obviously plants, like all living organisms, they need specific nutrients to thrive. These nutrients, or as we've been saying, essential elements, essential nutrients, are critical for various physiological processes, including growth, reproduction, defense, all that kind of stuff. There are 17 proven currently, /18, but that's only for legumes that plants require, categorized into, of course, macronutrients and micronutrients, and it's based quite literally, just on the quantities needed. So macro, it's more; micro, it's less. This presentation is going to break down each of these, give you a little bit of a tidbit on what each of them do. Yep. We're going to try not to get too stuck on any one of them, because again, there is 17 to get through.
Can I tell you, I've already just learned something. Okay. I did not know that the macro was called the macro, because it was just the three that were of
the highest quantity.
And it's
son of a bee.
And it's not. I mean, if you look at any bag, GRAMBO, those are the numbers they're giving you. Those are the NPK numbers.
Right.
And then,
yes, of course.
And then the other thing with that is, as well, they're mobile.
Yes.
Now, granted, something like calcium, not so mobile, but most of the macros are relatively mobile. Even magnesium is mobile-ish.
And even calcium, and we'll get into this a little bit more, but it's used as a secondary messenger. So even if it's not technically mobile, the fact that it operates in two different ionic forms,
moves in the transpiration
Ca2 plus,
stream.
Ca3 plus, right? So it's that electron transfer that creates a lot of the education.
I'm gonna get a pen. Hold on.
All right.
I can tell this.
All right.
We're just in the submarine. We're going deep.
We're going deep.
This was a fun one to put together. You want to slide that up just a touch?
So macronutrients, as we just said, they are needed in large quantities, and as Gabe mentioned, are mobile in the plant in general. So number one, nitrogen, good old N, right? People understand this as being something that's going to promote growth, create that green. We definitely know it's mobile because
of vegetative,
right? And if it's lacking nitrogen, right, it's going to get yellow at the top, or yellow at the bottom, because the plant's going to continually trying to put it up to the top, because that's a growth region.
Just for the people who don't know, do you want to explain?
I'll slow down.
No, dude, you get excited. It's okay.
I'm excitable.
Do you want to explain to people what mobile in the plant means? Just because I think a lot of people, when they see deficiencies, that's really one of the first things you should be looking for is, hey, I'll ask everybody all the time, what part of the plant? Is it the top of the plant? Is it the bottom of the plant? So maybe explain to our listeners what mobile really means.
Understand, and obviously, nitrogen, it's a major component of chlorophyll production. It's a molecule that's responsible for which is obviously the molecule is responsible for photosynthesis. So a plant's always going to try and be keeping it green. If it gets yellow, it means it's losing chlorophyll, which means it's losing its power plants, losing its solar panels, right? So with nitrogen being mobile in the plant, means
it can move around.
It can move, right? So what a plant's going to do, if it's lacking a mobile nutrient like nitrogen, it will take it from the bottom of the plant and move it to the top of the plant. So that's why you have yellowing down here, and you'll have, things are still nice and green on top. With a lot of the micronutrients, which understand too, before I go any farther, there's signs and there's symptoms. What we're looking at here is symptoms. And I'm here to tell you, diagnosing problems and trying to get solutions off of symptoms is the wrong way to do it. Why? Because a lot of them are the same thing. For example, overwatering and underwatering look pretty much the same.
Yeah.
So anyway, I always like to use that as an example, but you can use some of these clues to go, okay, it must be a mobile versus a non-mobile. So let's say it's a micronutrient that's lacking. Let's say it is something like calcium that doesn't move as well in the plant, iron, something like that. Iron, you get a little more intervenochlorosis, but anyway.
It's going to be at the top though,
right.
Still.
So it will be at the top. But again, if it can't move it, it's not able to take it from the bottom, move it to the top. So that gives you a little bit of an indication of what it could be. Reality is, we're dealing with an annual plant. Things happen very fast. So it's better to just take good notes and do it better, the next time.
It's funny even just thinking about it, because nitrogen, phosphorus, potassium, they're all light elements.
Yeah.
Like as far as on the periodic table.
Yeah,
So of course they're going to move through the plant more freely.
Sure. I think it's pretty understood and pretty well known that, nitrogen is a key part of amino acids, which are the building block of proteins, and very specifically nucleic acids such as DNA and RNA. So, all those things, all the genetic information that's withheld in there, right? Function wise, it promotes vigorous vegetative growth, as you mentioned, leaf development, overall plant health. Again, it's a macro. We use a lot of N. One thing about N2, it does come in by mass flow. So not only is it mobile within the plant, it's one of the only ones that's truly
foliar and
also within the substrate, right? It becomes in by mass flow. So it's actually water soluble. Everything else moves in by diffusion, which is more of a chemical or a chemical.
I can see a Graham question here.
While we're still on nitrogen, I do have a question. I'd heard that it's some of the tip burn is mainly like a nitrogen.
Well, if you would have just waited 30 seconds, you know what I mean? So that's the whole thing. That's why, that's why it can come in. When it comes in on mass flow, it means that it moves in just straight in the plant's not saying I want it or don't want it. And for the record, the plant can't really do that. However, there are proton pumps thing. There's a bit of an exchange process. This cation exchange capacity is the exchange capacity and the nutrient holding capacity the substrate has. That works in conjunction with the plant to allow certain things in. But diffusion happens, it's like a chemical movement that takes a little bit of time. Mass flow, it jumps right in with any water. And just that's why, GRAMBO, that's why you can actually truly burn your plants with nitrogen, but really nothing else. Okay.
Fascinating.
Now you can lock out your plants and have weird things happen with micronutrients and things like that. But the only thing, because of its mobility in water, that can actually burn a plant is nitrogen. That's the other reason why, historically speaking, a lot of times they said, go ahead and water out 10% beyond. Reality is, if you're running high EC, you're just kind of covering your ass, especially if you're using cheap nitrogen, which there are different forms of nitrogen. We're not necessarily here
nitrogen is the cheaper one, ammonium nitrate.
Well, yes, there's, and there's sourcing and things like that. And, by and large, nitrogen, it's not a mine mineral. So, you know what I mean? It is something that's created, which actually
go watch the nitrogen episode if you really want to know.
It's out there. But anyhow, that's one of the reasons why they would also have you kind of flow some of it out, because it was kind of just covering their butt to make sure that they didn't burn the plant. So what I mean is that a little bit of extra water helped push out whatever extra nitrogen would have been there that would have burned your plant. If you're just using high quality stuff and you're not feeding it too high EC, you really don't need to worry about the beyond saturation water.
The one thing I do comment to people is be cognizant of whatever nutrient line you're using and the amount of nitrogen that could be in there late in flower. You'll see a deeper, richer green in which, you're at week 7, you really want to be cognizant of trying to get that out. So no matter what line you're using, be aware.
So, and honestly, and understand too, nitrogen does come in some other forms. You can have either an organic based nitrogen, right, that needs to be actually processed into an inorganic plant available form. And just to remind you all, that is just a chemistry term, right? That just means carbon based or not carbon based. Organic is carbon based. Inorganic is not carbon based. Plants need or nutrients need to be in an inorganic plant available form.
A lot of cocoa companies will use like a cal nitrate as like a buffer.
Sure.
Am I correct?
Yeah. And and again, most of these things come in an ionic form. It's chemistry comes into, a big time play here. Hence, organic chemistry.
Explain to our listeners what ionic form means, just for the people who don't.
Well, so that would be the means of a particular molecule or element can operate in different. So whether it be like Ca2 plus or 3 plus, that's just the amount of electrons. Yeah. So it's not balanced, right? And if a molecule is not balanced, it's trying to either give away an electron or take an electron.
And that's where the covalent bond comes into,
So anyway, and again, I am no chemist, but I know a little bit about some things. So regardless, no matter what, the eventual uptakeable form is NO3 minus, which is nitrate nitrogen. It actually goes to nitrite and then nitrate nitrogen, whether you give it in an organic or inorganic form to begin with or not. And as we mentioned, deficiencies will show up on the bottom of the plant due to the mobility of nitrogen.
That's the big one. So, I always tell folks, where is your deficiency? If it's at the bottom and it's those yellow leaves, good chance it's nitrogen.
So moving on.
Into the P?
Phosphorus, all right? NPK, that's what you see typically. I wish it was NPK, calcium, magnesium. I wish they gave us 5 numbers, but, for whatever reason, it's required to be 3. And that is, let's say it's 10-10-10. That means it's 10% nitrogen, 10% phosphorus, 10% potassium. However, actually, it's not.
And that's the thing.
Minimum guaranteed.
We definitely want people to be aware of is if it says 10-10-10, that means it's at least those numbers, but could be more.
Could be more. Again, that's a minimum guaranteed analysis. And basically that's just.
I didn't know that till I started working for you guys. I'll be honest.
I don't think it's something that's commonly
known thing.
Understood thing. I almost think sometimes people think it's the other way around. It's almost the maximum, even though it's right there in the name.
Yeah, that's what I would have thought. I'll be honest with you, but guaranteed. Minimum analysis. Yeah,
it's right there in the name. Okay. Phosphorus, right? That's the second number on there. So the role of phosphorus is involved in energy transfer through ATP, which is adenosine triphosphate. That's basically the energy packets that is used within our cells and basically all living cells, and is crucial for photosynthesis, energy storage, and transfer. Obviously, very important. Why don't you talk a little bit about the function, Gabe?
It's essential for root development, flowering, fruiting, and seed formation. You and I had talked about this yesterday, but we've known people that when it comes to cloning, will preload, they'll preload their cubes with a little bit of phos. So it definitely becomes, is very important in the rooting process. It becomes unavailable pretty easily when the pH is not in range. So that range really teeters around that 5.8. 5.7 number, go figure. And a lot of times when people talk to me about having phosphorus deficiencies, the first thing I have them do is check their pH, check your pH of your media, check your pH of your runoff. 9 times out of 10, I'm going to guarantee that there's some type of pH imbalance. Truth of the matter is, most pH down that people use is phosphoric acid. So, I mean, you're adding phosphorus there. Mycorrhiza will form a symbiotic relationship with the plant roots, helping upkeep that or helping with the P uptake. That's something, that's why we always talk about why hypochlorous acid is not beneficial, because ultimately when you start killing all these mycorrhiza that are helping the plant, there's a conversion process that goes through and all these things. I was saying to someone the other day, like, no one just gets raw nitrogen or raw phosphorus, or they're all combinations of P2SO, whatever the hell it is.
Right.
They're all combination of things in which all of a sudden there are these different things, as we've discussed in different episodes, bacillus, mycorrhiza, that break these things down and make them available. So that's one of the big things that you have to be cognizant of, is if you're removing that component in the chain, then all of a sudden, you can put all kinds of phosphorus in there. But the reality is, phosphorus is the most, if you go and watch our phosphorus episode, it is the most limited element on the planet. And we by far dump the most of it into our soil and our water. When it's when there's an abundance of it in the water from runoff on farms, you see algae in ponds and stuff like that.
Eutrophication and some things like that. The reality is it's rarely is it actually deficient. It's just not available.
Yeah, and that's the whole. So that's more the point.
That's more the point.
What we're getting at is, it's very important for certain things, but again, the reason it's usually you see purple stems or whatever, and I know a ton of people that will justify having purple stems and LEDs. It's still a phosphorus thing.
Well, and again, I most times it's, and even if you look at the total substrate, there's a lot of phosphorus in there. It's only a very small amount that's available. And, to make more of it available, typically it's, some type of microbial action needs to happen. You know what I mean? And it's just, it's definitely a tough one. It gets bound up rather easily, but anyhow, that is phosphorus. How about on to potassium? So third number.
Why did, I never even asked this before, but why did they give it a K? Because they were out of P, I guess.
No, you know what? I don't even know. I mean, that's
it usually goes back to a Latin.
I was about to say,
we're talking about.
It always drove me nuts that 2 P's were the MPK, and I always created a stupid mnemonic device where I was like nitrogen, phosphorus, and potassium.
Wow. Okay. Well,
Potassium.
Well, we'll just call it potassium like it's called. All right. Its role, potassium regulates the opening and closing of stomata. Very, very, very important role. It's one of the things that I like to mention the most, right? Thus controlling water loss through transpiration, also influences over 60 different enzymes involved in photosynthesis. It's vital for protein synthesis. It helps move sugar from the leaves to other parts of plant-like roots, buds, and seeds. And unlike nitrogen or calcium, potassium remains in a soluble form within plant cells, making it highly, highly mobile. So even though the other ones, even if they're mobile, technically some are more mobile than others, obviously potassium being one of those. And a big part of that is because it needs to flow around, and with the whole stomata things, which is, the little cells on the bottom of the leaf are basically the holes in the bottom of the leaves, right? And that's where all gas exchange happens. And I remember when I was, if you really break it down, what does N, what does P, what does K do? Obviously nitrogen is cell wall formation. It's nucleic acids. It's, vegetative growth. Phosphorus, is more about fruiting and flowering. And then they always kind of said in school, potassium's for like everything else.
Yep.
You know what I mean? Yep. Just like it does so many different things. It's almost tough to say all the things that it does.
I meant to do a little more looking on this, but it's definitely very critical after the PK cycle, like after you use that, when you're out of that FOS kick, that cycle after that, it's very, very crucial in that part, because you'll see a dip if you're not you're not giving it an adequate supply.
And even if you think about, its general functions, think about how different all these functions are, right? So it increases drought resistance. That's one thing. It strengthens plant tissue. That's another thing. It improves fruit quality. That's another thing. And it helps with disease resistance, right? So it's like, obviously, clearly it's one of those things that just does all kinds of different stuff.
Crescent wrench.
Yeah. There you go. Calcium. There it is. Calcium, the crescent wrench.
So,
potassium, the crescent wrench.
The K.
Yes, the K.
Comes from Kalium in Arabic. So that's where they I had to look it up real quick.
So
but usually that's whenever there's something weird, it's like there's a linguistic.
It is because P was already taken. So they had to figure something out.
So on to calcium. So again, technically not mobile in the plant. So if you do have calcium deficiencies, you are going to see that yellowing up top in the plant, or even maybe some possibility of some intervanochlorosis. But again, it is a secondary messenger in the plant, which is very important, meaning that it's basically how the plant talks to itself a bit, right? So its role is calcium is important for the structural integrity of plant cell walls, acting as a stabilizer, also plays a role in cell division and growth. It's a key component in pectin. Which pectin is part of the cell wall, right? So you have
between each cell, there's that little stuff.
Because why? Because as we remembered in high school biology class, animal cell walls are single cell walled and plant cell walls are double cell walled. So you got cellulase, you got beta glucanase, and you have you have beta glucan, you have pectin, and you have cellulose. I named the enzymes that break them down on accident. But anyway,
whatever college boy.
That's the main components that you have there in the cell wall, but it is a double cell wall with that pectin in the middle. And so obviously, that's kind of the glue that binds. So very important there. It's taken up in the transpiration streams. It moves primarily through the xylem, which is going to be the dead cells that are in the middle of the structure of the stem. The outside being the phloem, the inside being the xylem.
One thing I really, this is something you say all the time about it being taken up in the transpiration stream. And I think it took a little while of you really saying it over and over and over again. But truth of the matter is, it's one of those things where that balance, we were talking about the VPD at the beginning of the show, but that balance of humidity, being able to have the stomata open and move that water through the plant is so crucial. It is so crucial.
It's a circle, right? Okay, so let's even talk about.
So you can give the plant tons of calcium, but if it's not transpiring correctly, it doesn't freaking matter. It doesn't matter.
Imagine this is a basic loop. So, like we talk about, Gabe, if I'm putting in 100 liters of water a day, how big a dehumidifier should I have? Something that can move 100 liters a day.
Yeah, I was going to say.
Okay, so people, it's not really drinking the water. Okay, it's passing the water through it. It uses the water as a vehicle to get elements and get nutrients. That's what the water is. It literally goes into the roots, up through the xylem, and ends up dumping out of the stomata on the bottom side of the leaves. That's why something like a terrarium works. That's a closed.
That guy's had that one for. I mean, I want to say it was closed for 60 years, like 20 years ago.
Yeah, exactly. So I mean, understand understand that like these multiple gas exchanges happen so you can create a world with, within itself that's a little micro world, hence a terrarium, because those gas exchanges are going both ways. So it's we oversimplify things sometimes just talking about, plants just provide oxygen, whatever. Well, the plants also in turn take up carbon dioxide. So it is a two-way system now. It's giving off, it's more oxygen, right, than it is taking CO2. So it's creating, a deficit on one side. It's not completely even, but point is, this stuff was figured out, man, but again, if the stomata aren't open properly, even going back to the VPD thing, right? Reason that's all talked about is you want to have enough humidity to where they're not reducing and trying to save water. You don't want the plant to be trying to save water.
Well, and I said I was on GRAMBO's show the other day and I had said, at 35%, it's like someone holding their hands around your neck.
So you can breathe still, but it's not wide open.
At 60%, it's like,
it's like a hyperventilating almost.
Well, and living out here in Colorado, I think it's easy to kind of understand that because when we go to the top, when you go up to Vail or you go up to Leadville and you go to 10,000 feet, it's just harder to breathe up there, and that's one of those things where you get down to sea level and you're like, wow, God, I can run way faster down here, and that's really what you're trying to provide for your plant and that's one of the beautiful things about indoor growing when we think about our friends up in Montezuma, those guys are at 10,000 feet, but with the right CO2 and right, supplying that environment, you are able to kind of make it perfect for them. But that is the biggest thing is that for every percentage of humidity, for every, degree of temperature, for all the CO2, there's a balance that comes into play in which all that stuff is in balance. And then all the elements we're talking about work perfectly.
That's the thing. It's all got to be in balance. And again, that's even kind of a law of the minimum thing, which is an episode that we did at one point in time, right? Your maximum is only going to be your minimum, right? Yep. So, don't want to get too stuck on that. But obviously,
the rabbit holes.
But they're fun, right? So, calcium also regulates nutrient uptake, promotes root tip and shoot growth, helps maintain proper cell structure. As we know, because it's not mobile, those deficiencies are going to show up in the top of the plant and can also end up with some blossom end rot type stuff. So you'll see that in peppers and tomatoes, right? And so that can be, funny enough, again, we're talking symptoms, unfortunately. So you're just seeing the end rot. That can be from two things, irregular watering or more commonly, your gardening tip of the week.
Great point with the irregular watering. Yep. I was about to say that, and that's a really great point.
And again, goes back to saying, even if a plant has enough water, like, calcium uptake can be, interrupted because maybe it's not flowing properly through there, and getting enough as far as a flow standpoint.
Well, and that's where that whole crop steering thing can get a little bit dodgy because some of those drybacks, you're messing with the flow of calcium through the plant. Yep. You know what I mean?
Yep. Anyway, let's get on to the
magnesium.
Number 5 magnesium.
Oh, yes. Well, magnesium is a central atom in chlorophyll, making essential for photosynthesis. It's also central for the ATP, which is crucial to energy transfer. Yes. We talked about ATP a little earlier.
Good old adenosine triphosphate.
Directly impacts carbohydrate production, so that it actually acts as an enzyme activator in various physiological processes. Very cool. So that's one of those things where, again, it does things that activate other things. So it's not necessarily crazy important because you need a lot of it, but it's making so many other functions happen.
Well, and again, weirdly, it also helps balance the calcium uptake, So even when we talk about something like whether it's nutrients, elements, biostimulants, or even hormones within the plant, it's like you can't just say an auxin does this because in certain ratios with other hormones, it's going to do this. In certain ratios with other hormones, it's going to do that, and so it's so many of these things. And that's why, obviously this is science. This is life. Life is so interconnected. I mean, if you really break it down, the whole way all of this works from a chemistry standpoint comes down to literally one thing: the polarity of water.
100%.
The polarity 100%. Of water is how that's the critical point of science and the unique aspect of it. And that's how everything works. Go down that rabbit hole, folks.
Well, and magnesium.
I'm too high for this episode, man. This is like, it's like quantum mechanics and stuff.
Magnesium is a unique one, and it's actually probably one of the easier ones to pinpoint the deficiency, because we always talk about how some, the micros will mimic each other. A magnesium, because it's mobile-ish,
Mobile-ish.
It's mobile-ish. It's not, it doesn't move very easily, but it can move. So a lot of times magnesium will show up in the middle of the plant as far as deficiencies. So that's one thing that's pretty kind of unique.
I really, really, really stress, be very careful about trying to diagnose anything off of a symptom. This is a reaction of what happened after the fact. It's already happened. So even trying to rectify that within an annual plant's lifetime is going to be rather difficult. So again, take good notes. Make sure you're basically remember guys, we're plant janitors. We're not growers. We don't do anything. We just provide them with the environment and the elements in the proper amounts to let them do their thing. So, don't overthink it. It's like when somebody calls up and there's like, hey, this one leaf looks like that. You know what I tell them?
Pull that leaf off.
Pick it off. Throw it away. If
it comes back and you see the problem again, now maybe we have something to talk about, right? So
anyhow, sulfur. Sulfur is a fun one too, because I think it's being the fact that it's a part of aromatic rings, right? So it's a big part of terpenes and things that are there and trying
Welcome to Flavor Country, son.
Flavor Town, terpenes, flavonoids. I always I got a thing for flavonoids. I don't want they get left out.
Yeah, you don't want them to be forgotten.
I feel bad for them.
And what about the thiols? Is that what the sulfur?
Now we're really
sulfur is like the thiols.
He's not wrong. He's not.
Esters.
Yeah. Don't get me going on esters.
Someday I'm going to get you going on.
Some days I'm going to get you going. All right.
They
so sulfur.
Have great pizza.
Sulfur is a component of certain amino acids, vitamins, enzymes. Plays a role in protein synthesis and is necessary for plant growth. Wow. You guys seeing a common theme here? Are you guys so you understand how intertwined this stuff is? And again, all this information we're giving out is only what science has proven thus far. So we only know this much about plants. Very, very, very little. Anyhow, moving on. Functions. It enhances enzyme activity and protein formation. Again, very common themes. Improves plant resistance to disease. So it initiates things like systemic acquired resistance, stuff like that. Aids in chlorophyll production. Geez, that's weird. A lot of things do, huh? And wait. So let me think here. So if everything now here's something for you. Everything that aids in chlorophyll production, what's that going to cause if it doesn't create that chlorophyll production? Yellowing. Might be up top, might be at bottom, might be in the middle. But if it's a problem with chlorophyll, that's going to create yellowing. So again, that's that problem in diagnosing on symptoms and not signs. Also enhances nitrogen efficiency, helps plants resist disease. Again, like I said, SAR helps with more pungent flavor and aroma. So that's one of the things I always like to really mention. Also helps with drought resistance and improving root function. That is so there we have it. Those are basically technically the macros. Sometimes even people will leave sulfur out as a macro. We decided to go with the, larger section of science that tends to put that in the macros. But again, we're splitting hairs sometimes on this stuff. So without further ado, let's get into the micronutrients, which as we mentioned right to start off, when we got to teach GRAMBO something right off the rip, which I always love. The fact is these are used in what, GRAMBO?
What?
Smaller amounts. Okay.
Yeah, okay. Hey, like I said, I'm too stiff. I was like,
and he's back.
I was riding an electron for a second, bro.
He hit that 7 beats per minute. You know what I mean? He was just really zooming, So anyhow, iron, take it away,
So
Gabe.
Iron is essential for the synthesis of chlorophyll, although it is not a structural component.
Again, do you guys see these themes? How many things have we said? This is everything, almost every single thing we talked about has somewhere in there said it has something to do with chlorophyll production.
So what it does, it's really cool, is it actually helps activate enzymes that support chlorophyll formation and is involved in electron transport during photosynthesis and respiration.
Yes.
So again, moving these pluses and minuses around. That's
And
what's
again,
happening at this point, in which that's a really important part of the chain. High pH can lock up iron. Nitrogen fixing bacteria in root nodules actually require the iron to function properly. So again, really a metabolite for other processes. It aids in energy production and is critical for proper enzyme function. So again, it's really just a catalyst, waking all these things. And when we talk about fulvic acid and we talk about how it's chelated and helping that iron work better, basically, like we say, iron's +2 +3, as you like to point out.
Yep.
And so
Fe,
plus
2 plus every 3 plus.
+2 +3s, they're a little bit harder for other elements to hook up with. So when it hooks up with the fulvic acid, makes it more available, makes it more appetizing to everything else. Higher phosphorus can actually can actually mess with the iron intake as well.
Ratios, again, like we're talking ratios. So to simplify it and say, hey, a bunch more P means bigger fruits, bigger flowers, that's a way oversimplification.
And then too much iron can mess with the uptake of zinc and manganese.
Again, ratios. Another little side note I'd like to make, again, just kind of going back and talking about how also pH affects it, right? And so that too high a pH, it's not that the iron's not there, it's just not uptakeable. So like for example, here in Colorado, right, we've got some people have chose to, come from other parts of the country and bring maple trees, for example, right? And you typically see these maple trees and they're yellowed out. They're so yellow. The interveinal chlorosis has gone beyond interveinal chlorosis and it's just full of yellow leaves. People go, oh my gosh, that's such a great color. No, it's actually terrible. And what's happening is that there's not enough iron available in a high pH soil. So what you would need to give it is a chelated iron, which chelate means claw, right? Talk about coming from Latin, right? But that basically just means it keeps it protected, keeps it from being bound up on the substrate and not available to the plant. So, it's all connected, folks. It's funny because all these things get oversimplified. And I always just like to make the point that we know these little things, but this is a system. It's all connected. There's no one thing.
It's like when I asked you about like Scietetics, gibberellins, and auxins, and I was like, oh, they all do this. And Jerin immediately popped out of an office. He's like, well, now hold on a second. It's about ratios and certain things do this and that. And
yes. I mean, in one situation, it can be, for root stimulation. Another situation, it can actually, inhibit lateral branching, for example, just talking about like auxins. And again, it's all about ratios. None of this stuff, really nothing in science. It's not just plants, but right, everything, for every action, there's a reaction kind of thing. You know what I mean? Just to kind of, wrap up that thought. Manganese.
I always thought this was a funny sounding element.
Manganese, molybdenum. We're getting into the fun ones now.
Because it almost sounds like magnesium, but you just stopped. It's like
correct.
100%.
Right.
It's like, did you just say magnesium wrong?
No, I said manganese. I did not.
Blah, blah.
Its role, it does play a role in photosynthesis. Again, especially in the oxygen evolving complex of photosystem 2, which is some really complex stuff. It helps plants split H2O to release the O. Very important stuff. It also activates over 35 enzymes involved in plant metabolism. And then, of course, if you've got waterlogged soils, because of the manganese content, that can actually create some toxicity issues. Its function, it helps in nitrogen assimilation and synthesis of some carbohydrates. You'll also see a little bit of a theme here. The deeper you go into the micronutrients, the less they know or can elicit out the specific little things that it does.
Well,
because
if you
just
notice, a lot of it does kind of very similar things, but also very specific things within them being similar, but all of them help with photosynthesis, let's say. But
chlorophyll production, photosynthesis, plant metabolism, it's like, all kind of there. So, copper. What about copper? Tell us about our friend copper.
Hey, imagine that. It's essential for photosynthesis.
Are you
kid.
serious?
It helps split the H2O and release that oxygen, and then functioning as a cofactor of several different enzyme systems. So again, it's really hitting switches, we'll say. It's making very specific things happen. One of the things that we're keen to point out is like, no matter what element, nobody puts raw elements in their plants. There's no just P or just K or just H. It's all different things that need to be broken apart by the plant, or by microbes or by bacteria or some type of enzymes. It doesn't matter, but there's all these different things where it's like insert tab A into slot B and then this happens.
Yeah.
So, and all these, this is exactly what they do, is they're different keys to unlock different things.
Even like we'll know it goes from an organic form of nitrogen, for example, to nitrite to nitrate. We know there's other stuff that happens in between there. We don't really know.
We just don't know.
We just know what it is. We know stuff does. Odds are it's literally going through so many different forms like that it's like literally can't even keep up with it, right? So to finish off copper, of course, it promotes, well, not of course, I guess I'll put this out there, but one of its other functions, it promotes seed production and plays a role in lignin formation, which also strengthens cell walls. Also helps with disease resistance by strengthening the cell wall, which is always nice, right? A lot of different things do that. But
we always talk about a thicker cell wall and how becomes more impenetrable to pests, pathogens, stuff like that. So it helps you really building, making sure that all these ratios are correct and building the strongest plants possible. Just like just like humans.
Yeah.
You know, it's the strong, if you're a strong human and you take care of yourself, you eat well, all the rest of that, when the flu or whatever comes through,
you can deal with it.
You have a better chance of walking through it.
Well, and I remember, one of those things that it was a true, revelation I had when I was in school for food crop production. It was like, oh, really? Organic food production is just about raising really healthy plants that can fend for themselves, right? So it's like when you talk about, even selecting transplants to put out there, is that thing where it's like almost good enough is never good enough, right? So you're never putting out weak things. You should never be putting weak stuff in the garden. That's why you do that 10 to 20% overages. Yes.
That's why you call things.
And sometimes it's hard. It's like when people get attached to the seed pack that they bought, so they want to make sure and find a winner. But reality is, not every pack has a winner, right? So it's like we get emotionally attached to plants. I know I do. It's like I'll take a clone off it. It's like I don't even want to get rid of this thing. Bro, I got to give it away.
I just did a whole run. My selection after it cured, I was like, not worth keeping.
Well, and sometimes that happens. Okay, moving on to zinc. I don't want to get too stuck up on these because we do want to get to the end without being an obscenely long video. But I think zinc's kind of interesting in the sense that, it's got a pretty unique role and it's necessary for the synthesis of tryptophan, which is an amino acid precursor to the plant hormone auxin, which regulates growth and development. And obviously, growth and development is a very general term, and that's on purpose because auxins do a lot of different things.
I was going to say, you love auxins, bro.
Hey, man, auxins are cool, man.
Don't get me started on indole-3-acetic acid.
Yeah, indole-3-acetic acid. Okay, all right.
Yeah,
one of its functions.
You were taking notes.
All right. It also
listen. I got ears.
It also aids in protein synthesis, growth hormone production, and activates over 300 enzymes.
Jesus.
And again, interestingly enough, based on a ratio, again, too much phosphorus can actually limit zinc uptake, and it also can be absorbed by Fuller sprays easily. And I'm assuming that's probably because of its small molecule size. It's got to be able to get through those the pores that are in the cuticle. The cuticle being the waxy layer on the outside of the leaf.
I've used copper sulfate in the past. I can't remember, but you don't really see that.
No, you don't see that a whole lot. Okay, boron.
Boron, dude, this is the big one.
Boron,
big one, small one. You know?
Big, small one. And honestly, it's an interesting one, and it doesn't get a whole lot of love. So let's give boron some love today,
dude. Boron is essential for cell wall formation and stability. It's crucial for reproductive growth, including pollen development and seed production. So if you're a seed maker, that's a good tip to know. Helps regulate carbohydrate metabolism and is important for root and shoot growth. So again, it helps regulate some of those sugars around the plant. The big thing is it can bioaccumulate. So whereas most elements have a half-life, if you're going to give it too much boron, that's the type of thing where I've had people test hot because they weren't aware. Now, granted, I went and did research for those people and it ended up, I think they had too much boron in their cocoa.
Sure.
But the reality is it bioaccumulates. It doesn't break down.
And toxicity or boron toxicity is a real thing.
It's a real thing.
And it's even something we talk about. If you look on the back of the bottle, one of the carrier molecules of our mono and orthosilicic acid, Slicium, you see borons in there. It's one of the reasons why it's used in such a small amount at that 0.5 ml a gallon.
And it's best at frequent small doses.
Frequent small doses. Yep. And that's why it's in there. Again, it's part of the molecule that is the carrier. So that's part of the reason that it's there. But understand that even these, less sexy, micronutrients, they all do really crazy critical things and truly have been proven that they are plant essential. So very, very immobile. I think that's one of the reasons why, even the bioaccumulation factor of it, it's its lack of mobility. I don't know that for 100%.
Well, think about it again. I think it's heavier. So
yes.
for it to move through the plant, it just takes more energy.
And then weirdly enough, high calcium and too much calcium can actually limit boron uptake. So again, balanced nutrients, not looking at one, like so many people like to, let's fix it with this or fix it with that or whatever. And that's, you can kind of, I think, understand and see some of the, you know what I mean? And people just trying to overdo it.
Like a calcium toxicity might be manifesting a boron deficiency.
Now we're thinking and now we're talking. So just trying to literally dumb it down.
Even
to
just
one,
talking about it more and
doesn't
not
work
for
like
nothing. There's only going to be so much room for things if boron's the heavier particle, it's going to stay behind.
Yep. Again, just to remind, it is best in frequent but small doses. Okay, next, Molly, our friend Molly, molybdenum.
You guys know what it's about.
Hello.
You need a molybdenum fertilizer. We got you.
We got it. Yes. And the good old Ruby Full, right? It is actually registered as a molybdenum fertilizer. Now you need to be careful if you're using it on any plants or any crops you'd be using with ruminants. So don't go dumping a bunch of it on your hay fields. But that's just because it's an interesting ruminant problem. And you'll actually see the note on the back of it. But anyway, that happens to do with molybdenum. If you can move that up just a little bit there, GRAMBO. So its role is a component of enzyme nitrate reductase, which is an enzyme which promotes the chemical reduction of a specified substance. It is also involved in the nitrogen fixation process and nitrogen metabolism. Pretty important stuff. Function helps convert nitrate into usable forms for the plant. So nitrate, or it's probably nitrite into nitrate actually. But anyway, essential for nitrogen assimilation, can improve phosphorus uptake. Strange. It's one of those things. And again, how they improve some of this stuff is just almost beyond me.
The thing I thought was funny is that unlike the other micros, it actually is mobile in the plant.
An interesting thing about it, no doubt. And in general, we think about macros being mobile, and in general, we think about micros not being mobile. But as you can already see, that's not a hard and fast rule. That's more of a
It's funny because when I think about it, so one of the larger molybdenum mines is actually here in Colorado. It's in Climax. It's the mine between Copper Mountain and Leadville. In which, that's where the birth of the Leadville 100 came, all the rest of that stuff. But they use molybdenum as an additive to stainless steel to decrease friction. So it's kind of funny that it's mobile in the plant because I think with that decreased friction,
he's like, I'm trying to tie
it's just like slippery.
Tying some stuff together. Why don't you get us going on chlorine there, Gabe?
Chlorine plays a key role in osmosis, ionic balance, photosynthesis. Again, particularly in the water splitting reaction of photosystem 2. So again, there is, for those of you, we'll get into it in a second, but nitrogen or hydrogen being 45% of the plant, there needs to be some breaking in order to get the hydrogen away from the oxygen. So it helps in the water movement and acts as an important part of the defense plant mechanisms as well. And it helps regulate the opening of the stomata.
So I know it's funny with stomata. A lot of times people just talk about potassium, but in truth, there's obviously, again, it's ratios. There's several different elements in different ratios that actually help with that. Next is nickel. Good old nickel. Its role is a component of urease, which is an enzyme. Anytime you see a ASE. That means it's an enzyme. Pectinase, beta-glucanase, urease. So it's obviously going to break down urea.
Dude, nice tip, bro.
Yeah, dude.
Nice
check it out. Check it out. An enzyme responsible for breakdown.
OSE is usually sugar, right?
Well, again, these are, that's the thing. Glucose, sucrose, things like that. All these things, they're chemistry conventions, right? So it's like, that's how you can actually, just by the word of the chemical compound, what it is, right? Because these are all like, it's language conventions, believe it or not. Anyhow, it's aids in the breakdown of urea, as we said, being urease, and usable nitrogen for plants. Its function supports nitrogen metabolism and helps prevent toxic accumulations of urea in plant tissues. Very interesting. Also regulates iron metabolism. Again, it's hard to, okay, all right. Cobalt. Cobalt, okay. So here's the one thing that's interesting about cobalt. This would be if you get into, is it 17 or is it 18? Because there are certain people.
We're going to talk about silica.
Which you could even call possibly 19, but hasn't been necessarily proven. So cobalt is sometimes considered essential for legumes. Legumes being things like peas, beans, stuff like that. Legumes do create nitrogen. They actually put nitrogen back into the soil based on the nodules that are on the roots. Pretty interesting stuff. So anyhow, we'll talk briefly about cobalt. So if you were talking about peas, it would be, I guess, crucial, essential. It's crucial for nitrogen fixation in legumes. So obviously pretty important considering it's putting nitrogen into the soil, and is required by nitrogen fixing bacteria in those said root nodules. It's essential for nitrogen fixation to legume growth. It is obtained from air and water. So both sides. I found that to be very interesting, being that it's that quote unquote, flexible, and that it's so associated with legumes, which are super unique in the fact that they actually create nitrogen and leave more in the soil than when they came in. Very interesting stuff. Carbon. So now we're actually going to get into the last few, which these are the free elements, right? Reason being is they're all actually gotten from the air. We're not really giving it to them, right? So carbon, CO2, carbon and oxygen, right? Pretty easy to see how where free that carbon would come. Well, it's 420 parts per million ambient, my friend. And so for a C3 photoperiodic plant, which is what we're dealing with, it's actually well above what's needed to maximize before it becomes, kind of that flattened curve, and the return on investment becomes nil. Anyhow, carbon role is it's a primary building block of plant cells, and it is a key component of carbohydrates, proteins, fats, and DNA. Everything, right? Literally almost 50%, 45% of the plant is made up of carbon. It is taken up as carbon dioxide, as I mentioned, during photosynthesis, and forms the backbone of organic molecules in plants. Hence, organic, inorganic, all based on carbon. So
carbon-based life forms, my friends.
Carbon-based life forms. And then, we always like to mention the ruby fulvic when we talk about carbon, of course. Reality is ruby's really just, I think, our favorite product to try and just wrap everything up and just maximize uptake.
It just works, man. It's just going to make your stuff taste better.
And the reality is, when you talk about something like carbon, that means we're going, again, back to that whole proper environment to keep the stomata open so you can keep this all ripping through, so you get that CO2 plant, exchange. And when you're using the ruby to actually to condition the substrate for maximum nutrient uptake and efficiency, that's going to help basically be able to take on everything else, right? Again, it's all a system.
I think it is the most overlooked element. I think so many people just don't realize that it's that much of the plant.
Well, again, that's
they're so focused on the other 14.
Sure. But that's 15. It's so essential, yet, but again, it's right there in front of you. It's photosynthesis. It's like CO2 we talk about all the time. People go, what? Plants 45% carbon? Yeah, it's kind of like the whole deal, man. Anyway. But let's talk about hydrogen.
So hydrogen is obtained from the water, H2O. It's a component of all organic compounds and plays a role in energy production and photosynthesis. So as we were talking a little while ago,
and again,
there's, it gets broken off, or the oxygen goes away and does other things. And then, so there's processes that happen in there to get that hydrogen, but it also is 45% of the plant. So now we have talked about 90% of what makes up the plant, but it's used in photosynthesis to produce sugars and acts as a carrier of energy to form in the form of ATP, which, as we discussed earlier, is adenosine triphosphate.
So I also like to mention, what is carbohydrate? It's a sugar. It's C6H12O6. So where is that? That's carbon, that's hydrogen, that's oxygen, right? And we got to get it from some different places, and we got to break it off and then reconnect it. And it's a whole process. It's very complex. It's very amazing. That's what makes plants. There's a lot of stuff
that goes into
autotrophs and not heterotrophs.
Rearranging.
That's the whole thing.
Molecules.
Yes, that's really, and it takes energy to, you have to put in energy to be able to break certain bonds to then reconnect everything up, and then you're going to end up with more energy on the backside. But this is complex stuff. It really is. Okay, number 17, depending if you're counting cobalt, or number 18 if you are counting cobalt, is oxygen. Last but certainly not least, oxygen is involved in respiration, which is the other side. You got photosynthesis and respiration. That's the other side of the chemical equation, right? You have to balance the chemical equation. So it's photosynthesis, respiration, which is again why a terrarium works, right? Okay. Anyhow, so oxygen, obviously respiration, it helps release energy from organic molecules. It's taken up from the water and air. Oxygen is necessary for cellular respiration and energy production in plants. It's oxygen, man,
and it's oxygen.
It's oxygen, man.
It actually makes up 2% of the plant. So now we've
92.
Now that's 92.
I'm not a mathematician, but
and then the other parts, they're 8%. You know what I mean? In which, as we always discuss, what is plant food really? Plant food is light. In which a lot of what we've discussed here, and when we've talked about all these things that aid in photosynthesis. That's what's happening. That's what's happening.
These are just initiating certain process and building blocks and stuff. But funny enough, it really isn't food per se. Right?
Light is plant food. Light is plant food.
Why? Because it's capturing that light and storing it as food, right? And so therefore that truly is the food. So last but certainly not least, we wanted to talk about silica in part because I personally think that a lot of people consider it to be a plant essential or just assume it is a lot of time.
Maybe in the 21st century. It will be.
We don't know. This is dynamic. This essential beneficial. This is a moving line. This is dynamic.
We need the red hats that say make silica an element.
We'll see. You don't know. Maybe we can start up, hey, for everybody out there, let's get silica on the board. But here's the deal, right? So the reality is though, even though it's not proved to be plant essential, we all know that it's plant beneficial.
It does cool stuff.
It does cool stuff, right? And especially if you have something that's completely bioavailable, like a mono and orthosilicic acid, such as our silicium, you're going to be able to increase plant vigor and increase ability to resist diseases and pests and things like that. What I like to do is call it liquid insurance, right? And the reason being is you don't need it until you need it, right? So let's say everything's rocking along and it's perfect and I watered perfectly every time. Well, no big deal. Do you absolutely need it? No. But the day I forget to water and I come back in and that thing has actually saved my garden, well, there's your liquid insurance. So what it's really going to do is, in a nutshell, and I'll get a little more specific, but in a nutshell, it's going to reduce any and all abiotic and biotic stresses. Abiotic being things like drought stress, heat stress, cold stress, things like that, right? Being more environmentally based. And then abiotic, obviously being pest diseases, things like that. So of course it strengthens the cell wall because literally what's going on, if you look at the molecule itself, you can kind of see it literally goes up, dumps silica into the cell wall, and then the rest of it, the oxygen and the hydrogen that's in that same molecule just get dumped right out in that process that we know as transpiration. It does help with drought stress immensely, folks. I'm telling you right now, I have grown very large plants in solo cups and should have had a lot of things die.
I've walked in on plants that were dead.
Yeah.
And I watered them, and then you came back in the room and you're like, which one is it again? I can't remember which one it was.
So again, enhances pest and pathogen resistance, helps with nutrient uptake, helps with photosynthesis efficiency.
And with that thicker cell wall, it just makes it harder for the pest's little jaws to penetrate. It makes it harder for on a powdery mildew. It makes it harder for the hyphate to penetrate that cell wall.
Yep.
So that's really where that's where the benefit is.
And it is more of a mechanical thing, which is totally fine, right? But even there's been certain products I've seen out there before.
Giving it a thicker skin.
Yeah, giving it a thicker skin, man. Giving it that alligator skin. And in reality, I came up with that. I was at the top of my dome. One product I actually saw at one point in time that just said plant vigor. It does give it just that vigor. It gives it a little bit of that shine. You can foliar feed it, folks.
I was about to,
2 mils a gallon.
That's how I use the silicium. Yeah. It's because I always hated the fallout. No, I'd always get fallout. It'd annoy me. I'd pour it in. I'd let it Well,
the original ones on the market, actually, they would tell you to bubble them for 24 hours. And the reality is because that molecule size was very, very large and needed a little bit of time to knock off small pieces. It could be uptakeable. Ours, specifically in patent, is reduced at a low pH, so it actually lowers your pH a little bit. Doesn't raise it, which most silicas do, but that's potassium silicate. Mononorthosilicic acid, which could be considered interchangeable because that's just the form, that's the flip-flop form of it, right? It's a bioavailable form of potassium silicate. So potassium silicate isn't bad, but again, like we were talking about, these conversion processes take time. You're going to be better throwing a potassium silicate on your trees and shrubs that are going to be there multiple years as opposed to any annual plant such as vegetables or cannabis or anything else, right? Because you want that to be immediately available. And the reason that ours is immediately available and goes right into and is water soluble as well, which is rather unique, is because it stabilizes monomers, dimers, and trimers. So it's 1, 2, or 3 molecules of mononorthosilicic acid.
Can I say, what else is immediately available? Is all of these products on jugdealers.shop.
Hey, I love that. That is fantastic. Keep in mind, folks, each of these 18 essential elements, or 17, depending on what you're doing, and one beneficial, the silica that we talk about, plays a specific and vital role in plant health and growth. A deficiency or imbalance, along with pH inconsistencies, and any of them can result in poor growth, reduced yields, and even plant death. Understanding the function of these elements is crucial for proper plant nutrition management, ensuring optimal plant performance performance. But again, remember, the plants are smarter than we are. They are autotrophs. We're heterotrophs. We're out there trying to find our food. They're badass enough making it. So just give them the few things it needs. Give them a balanced diet. Give them a good room. Give them a good environment. Have great genetics, and you will have great product.
And remember, check your pH, kids.
Yes.
Check your pH. Don't go calling us or any of your other people and say, I have a phos deficiency. If you reach out to me and you say you have a phos deficiency and you haven't checked your pH, there's going to be problems.
Keep in mind, this is also pH going in and pH going out.
Yes,
if you guys do want to, there are, and this is obviously, you can do some
way to point that out, bro.
And if
Media
you really
dictates pH, people.
Stuff's going to happen. So keep in mind too, there are, and you can look up, there are some specific processes to actually, really properly measure your
NC state port extracted media method. You guys can go look it up.
So it's going to tell you really how properly. Obviously, you can just get a decent indicator. Whatever runoff you have, collect a little bit, pop a pH pen in. It's all right.
Sensors. There's so many different ways to deal with it. I know the guys at GrowLink have different, and there's a lot of different people who have sensors to be able to do this stuff, but poured through extracted media test always works. And Jerin made an extremely important, good point in the fact that check your runoff.
Check the runoff, folks. And hey, just remember, it is getting into gardening season as well. Get those veggie seeds. Shout out to Baker Creek Heirloom Seed Company, the largest heirloom seed company in the world. They've got some of the coolest stuff out there. But yeah, we're getting into gardening season. We'll continue to talk about some of those topics, which is always a fun time of year for me. So anyhow.
Hell yeah. Hey, do me a favor. Reach behind your head and grab that bottle of, you knew what I wanted.
Yes.
I actually walked into the office today and I was like, my what, Jerin?
So we don't ever.
Your Tradescantia.
My Tradescantia is it needs a little something. I noticed the one at the office is looking good. They handed me a bottle of
So we don't push this one that much because I'll be honest.
And this one's actually not available on the Jug Dealers shop. You have to go to the magnificentgardens.org to.
But it is available there.
But it is available.
It is Jeff Lowenfeld.
Yeah,
Jeff Lowenfeld's
approved.
Yes, Lowenfeld's approved.
I got one without a label, so I feel special. They just gave me right out the case.
At 5 mils a gallon, it will act as a catalyst. I use it with my new Millennium. I'll use it like once a week. I'll be honest with you, my Gorilla Glue tastes fantastic, and I think that's a big part of it.
That glue was a phenomenal.
Yeah, it tastes amazing. And then if you need to bump it up, 15 mils for a feed.
Oh, yeah.
House plants, tomatoes, cannabis, it doesn't matter.
You can use it on a lot of different stuff. And again, you can use it in more that synganic approach, just put it in and give it a little bit more life back in that substrate, which is the way I like to look at it.
Living soil, guys.
Absolutely. I use it heavily in my my organic veggie garden as well. So come and get it. Magnificent Garden. Any of these other products, as we said, are available on jugdealers.shop or magnificentgarden.org, as the case may be. Oh, and I would be remiss if we didn't mention
shout outs, bro.
We definitely need to do shout outs real quick, but also if you do want any bookings, things like that, you can request that. We do have jugdealers.net/bookings. I believe that even Mr. GRAMBO, man behind the glass. Yeah. Nice to have you, GRAMBO.
And you can go just on jugdealers.net. There's actually tabs. So you can just click the sample tab. You can click the bookings tab. And there will be a club tab coming soon.
Club tab coming soon. I know we've been talking about this, but we really have been actually working in the background. It takes a little while to set these things up and do it proper. We're trying to figure it all out, point system, etc., kind of how this is going to work, but definitely be looking for it. We'll have exclusive discounts through there.
Discounts, schooling, bundles,
all this.
Points.
Behind the scenes as well, hopefully.
Yeah, well, one thing at a time, you know what I mean? We'll take it. But yes, there's going to be all kinds of new content. Anyhow, so everybody, welcome back. Let's get right into this. We wanted to shout out for you listeners, so I don't think GRAMBO, you got that for us?
GRAMBO, who are the listeners we're highlighting this week?
Yeah, so one of our top commenters is also the creator of the theme song, and we'll give him a shout out here. Cannabis Vibe. He's hardcore. Vibe. He's called THC for everything on his other social media. He created the theme song, and he's one of our top commenters.
He's always.
Thank you, sir. Very much appreciated.
Shout out to always tuned in, dude.
He is always there. And shout out to Tark. We see you, Tark. You see you. You're always one of our top commenters. And then let's see. How would you say this? Chuck Palanetti. I think if I'm butchering your name, brother. And then we'll round it out with the Blizzard of Za, which I said would be a great pizza name, like a metal pizza place, like Blizzard of Za.
Have you ever seen the old school Blizzard of Oz, the old school ski video. Yeah, dude.
Oh yeah, it was.
No.
Is that?
Dude.
That's.
I want to say
that's Glenn Plake, isn't it?
I think so. I even think is Tommy Moe even on there? I mean, there's definitely some.
For those of you who don't know,
on there as well.
It's like a skateboard video, but for snowboarding.
Yeah, for those who don't know, Glenn
hot dogging.
Glenn Plake was the guy in the 80s who had the real giant pink mohawk or whatever color.
Yeah.
And the dude was a shredder. I actually still follow Glenn Plake, and he's the coolest dude.
Blizzard of Oz. If you guys haven't actually seen it, it's an awesome old school, kind of early before some of the stuff was done, ski video. Anyway, just reminded me of that. But thank you guys so much for tuning in. I hope you enjoyed this episode. Until next time, from the Jug Den.
Peace.
Peace out.